The question is how to solve the Joker robbery game with 5 people, which is actually the number of people in the movie, or maybe 6, I don't care, but say it's 5. Then let's start drawing the tree. So the first player can choose to not go or go, and if I choose to go, then the second player can choose to kill or not kill him. And similarly, we can have a third player, kill or not, fourth one, kill or not, and always saving the last one as Joker. So, by the way, the trailer of the new Joker movie is out. It's this Suicide Squad movie, so if you haven't checked it out, you should. And anyways, going back to the actual game, so without actually writing down those numbers, because numbers just represent utility, so if you can figure out utility in your head, then that's okay. You don't even need to draw the tree. But in any case, the Joker has a dominant strategy, right? So no matter what happens, because there's no one after me, I'm the last one, so I always kill, because killing the previous person will actually, I will have all the money. So that's the dominant strategy, so I always choose this. And then going back one level, the fourth guy, knowing that the Joker will kill for sure, then I won't go, because if I go, I get killed for sure in SPE. So then we move on to the previous person, knowing that the fourth person will not go. If I kill the previous person, I can get all the money. So I will actually kill. So, and given that the player 2, knowing that the player 3 knows that the player 2 will not kill, player 2 is sure that player 3 will kill, so I will not go. Because going gives me, I'll be dead. If I not go, then I just don't have money, which is okay. And that's why, and player 1 knows all that reasoning afterwards, so I can reason through everyone after me, like the way I did. Then I choose go, because after all those reasoning, I see that player 2 for sure will not go. So that's why I will be going, and this structure is the SPE. So the red one is SPE. So finding the Nash equilibrium, I think one interesting thing is that you can actually find the first type Nash. So which I mean, on an off equilibrium path, I can switch and make equilibrium stay like this. So first thing, again, this is the equilibrium path. It ends here. It does nothing, has nothing to do with all the other players. So if I switch, so all this, and this are off equilibrium. So, but you probably see that if I modify these two, then it will probably change something. But if I modify the Joker's behavior, it will change nothing, because it does not. It's too far away from the equilibrium path. So when I change, because it does not, it kind of affects the fourth player, but fourth player's action does not really matter. So that's why this one. So G, N, K, and N. So the first SP is G, N, K, and K. Then this one is the first type Nash that we mentioned. So suppose we go back. The thing is, unequilibrium switch needs to work. So one thing I can do, and the obvious thing is, those are the only two things that I can change. So I'll change this one and see if we can change the behavior. So making an unequilibrium path change, I will change to here. Then for the first player, I'm deciding between go, then I follow the whole path down here, then I will be killed at some step, so I don't want to go. So now I switch to N. So this is a Nash equilibrium. So N, and the second person choosing to kill, 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 kill. This is a Nash of the second type, where I make it so I lie on equilibrium, so that we change the equilibrium basically. So those are the 3 Nash that are obvious. There are a lot of Nash equilibrium for this game. So on the exam, again, you don't need to solve for all of them. Just these 3 are the most obvious ones, and you just need to know how to get these 3.